We're going to look at one more type of proof by induction question at the moment. We will see proof by induction a few other times throughout the course. This is the last one we're going to use right now. And there are two useful algebraic techniques for this one. And we're going to be looking at these which involve sigma notation. So the first one is that if we have the sum from 1 up to 5 of some function, in this case that's just 1 plus 2 plus 3 plus 4 plus 5, then that's the same as doing that same sum from 1 but up to 4 and then adding on the fifth term. That is, we use 1 plus 2 plus 3 plus 4 as a sigma notation, and then we do the plus 5 as a separate thing. In general, that means that the sum from I to n of some function is the sum from I equals 1 to n minus 1 of that function. And that whole sum plus what happens when we evaluate that function at n. So if we evaluate this function at n, we get the last term, and then we add the rest of them before that. The second useful algebraic thing here is being able to factorize more complicated expressions. So we know that we can factorize 3k plus 5ak by bringing the k out the front. We get left with 3 plus 5a. But if you look at something like this, 3k plus 1 plus 5ak plus 1, it has exactly the same structure. Instead of k, we have k plus 1 in each case. So here we can factorize out to k plus 1. What do we need to multiply k plus 1 by to get 3k plus 1? 3. What do we need to multiply k plus 1 by to get 5ak plus 1? 5a. So these two algebraic rules are going to help us as we go through this next set of proof by inductions using sigma notation.